let's talk a little bit more about what it really means factoring polynomials graphically, right? We already talked about what it means to factor polynomials, which is basically just breaking them down to its core elements, right? But let's take this a little bit further and just visually, graphically show what it means when you actually take a polynomial and you factor it. Now, when you're factoring numbers, just straight out numbers, we've already talked about this in series 1, right? You just take a number, whatever integer it is or whatever rational number it is, and break it down to its prime factors, right? For example, 6 breaks down into 2 times 3. For example, the number 6 you can break down into 2 times 3, right? And what we end up doing with polynomials is taking a polynomial and breaking it down to its prime polynomials, right? Breaking down to smaller degree polynomials, right? For example, if we had the following polynomial, and we've already talked about this, we can break this down in the following form, right? So if we take the polynomial x squared plus 5x plus 6, we can break it down into x plus 2 times x plus 3, right? So all this is really is just one function, our original function that we were given. If they say factor this polynomial, we take this polynomial and break it into 2 smaller degree polynomials. When multiplied together, give you the original polynomial, right? Which is really one function is equal to 2 other functions multiplied together. So the way we can think about it is this polynomial, this function, we could just call f of x. So f of x would be this guy. F of x is equal to h of x times g of x. And this guy would be our h of x, and this guy would be our g of x. Now, this is just basically terminology-wise, right? Graphically, we can, present this graphically. And graphically, this is the way it's going to look like. This guy is a parabola, so we're taking our parabola and breaking it down into 2 functions that aren't parabolas multiplied together to give you the parabola. And these 2 guys here are linear functions, they're lines. So 2 lines multiplied together give you a parabola, and this is what it's going to look like. So our polynomial here, x squared plus 5x plus 6, is a parabola, and its x-intercepts are x is equal to -2 and x is equal to -3, right? We already talked about this. When you factor this guy, if this guy is equal to 0, all you're doing is finding the x-intercepts. So you can set each one of these equal to 0 and solve for them, right? So this is x equals -2 and x equals -3. So it's a parabola that crosses the x-axis as x equals -2 and x equals -3. So we got our parabola. This guy graphs something like this, and we're going to talk about graphing polynomials, more accurately when we get into graphing polynomials, when we start talking about completing the square. But this guy would be our f of x, right? So this parabola, if you break it down into smaller polynomials, is going to be 2 lines multiplied together to give you the original function. So what we have here is our h of x is basically y is equal to x plus 2. And again, we'll talk about graphing linear functions if you look into the polynomial section. If you're looking at this right now when I'm putting it up, I haven't done it yet, but we will talk about graphing linear functions. So this guy, x plus 2, is just a line. It's a linear function with y-intercept of 2 and a slope of 1. So all you do is you find your y-intercept and go up 1 over 1. So that graphs a line, right? The other guy is also a linear function, a line, linear line, right? With y-intercept of 2 and a slope of 1, which is this guy. So if you take these 2 functions, multiply them together, you get this function. If you take these 2 lines, multiply them together, you get this parabola here. And this should be like, hey, wait a second, how can we multiply 2 lines and get a curve? Well, if you remember from series 1, what's 2 negatives multiplied together, right? They give you a positive. So over here, we go down into the y equals negative. Down here, you got y is equal to negative, right? So 2 negatives multiplied together to give you a positive. So it kicks the function back up. Over here, between -2 and -3 here, we have part of the function here is negative, or this function here is negative when it goes below negative 2, right? When you go past negative 2 on the x-intercept, in the y-section, you're negative here. Over here, negative 2 is here, and that's going to be positive for this function, right? So negative times a positive over here is going to kick you still in the negative section, right? But as soon as you go past negative 3, or what is it? Negative 3 here, right? Your x-intercept is negative 3 as well. As soon as you go past your negative 3 here, then this function is negative, and this function is still negative, right? So negative and negative kicks you back into the positive in this section, right? So two lines multiplied together give you a parabola, as long as the lines, they go into, both of them go into the negative, as long as their domains, whatever their x can be, continues on forever, right? So factoring integers, factoring rational numbers is just like this. It's just, two different numbers multiplied together to give you the original number. Factoring polynomials is just two other polynomials multiplied together to give you the other polynomial, the polynomial you started with. Graphically, it's whatever these polynomials graph. Now, they don't have to be linear functions. It could be curves. It could be other polynomials, right? These two polynomials multiplied together give you the original polynomial. And that's what factoring is. We're taking things and breaking them up and seeing, what they're made out of. And that way we can take, maybe we want to take this part, whatever this thing is, and multiply it with another function, right? This part of the function and multiply it by another function just to create a new function, right? And that's what it is. That's what factoring polynomials means. You're taking, graphically anyway, you're taking a function and breaking it up into two other functions multiplied together. They may be lines, they may be parabolas, they may be quartic functions, cubic functions, they could be anything, right? And they don't even have to be polynomial functions. They could be non-polynomial functions, right? Things that have asymptotes, things that have, unknowns, vertical or horizontal asymptotes, right? Things that have breaks, that have holes in them, right? You could take any type of any two functions, multiply them together to give you a new function, and from that new function you can do new things or apply them in new places. Okay, that's what factoring is. Factoring a polynomial, break it down to its functions. Factor a rational number, break it down to its prime factors, right? Factor a polynomial is just a graph, right? It's just a graph of a function. Break it down into its new functions.